Is it possible to score 80 and above in physics? Of course it is possible, because in this video I'm going to expose all the questions that JAMB has been repeating all over the years. And even if they change it, because they repeat question, they can only change the values, okay? So when you understand the concept, it's going to give you edge to solve those problems. Even if you are scared of opening your textbook, I'm going to give you a detailed explanation that will give you edge to go back to your textbook and solve the rest of the problems. With no further ado, let's get right into the video. Which of the following is the dimension of pressure? Option A, ml power minus 1 t power minus 2. Option B, ml t power minus 2. Option C, ml square t power minus 3. Option D, ml power minus 3. Now, even if you don't know what is pressure, you don't need to be scared. What is pressure? How do I get the dimension of this pressure? You don't even need to cram the formula for pressure for you to be able to remember it. One thing that you must note about pressure is this. What is the definition of pressure? How can we define this pressure? So let's go. Pressure P is equals to force over what? Area. Right? Now the next thing you ask yourself is this: what is force? Let me explain the way you understand. What is force? Force is equals to mass multiplied by what? Acceleration. Now, that is the first thing now. The second thing you're going to do is this. What is the unit of mass? That is kilogram, right? So I will now say unit of mass is what? Kilogram. Now, what is the unit of acceleration? That is meter per second square. So I will now say multiply by meter per second square. Is that clear? Now, looking at it, you're just going to multiply it, okay, by saying that unit of force is kilogram meters per second square. This is unit for what? Force. So we can now put it here and work it out. So let's go. Pressure is equals to, instead of writing force, I'm going to write the units, right? Which becomes kilogram meters per second square. So this is kilogram meters per second square, right? Okay, look at what? What is area? Area is meter square. Remember, area is length times breadth. And any short distance is measured in meters. So let's go. We divide by what? Meter square. Remember, from the law of indices, I have something like this. For example, I have A over B. From law of indices, what am I going to do? I want this B to come up to the numerator because it's in the denominator. As it's coming up, it's going to carry a negative sign. A negative sign, that is, this is AB minus 1. Do you understand? So, using this knowledge, we can apply it here. This meter square is in the denominator. I need to carry it up to the what? Numerator. Simply by what? Taking it up and add what? Negative sign. I hope that is clear. Okay? So this becomes kilogram meter per second square. Then I'll say multiply by per meter square. Do you understand? So this is for my pressure. I want to work it out first to get the unit before I can talk about the dimension, okay? Now, look at it. From the law of indices too, we have meter here and I have meter here. So I'm going to do what? Add them together. This one have, anyone that does not have any power on top already have invisible power of 1. So this is power of 1 and this is power of minus 2. Is that clear? So what I'm going to do is, because the bases are the same, from the same law of indices, let me shock you. I have that what? If A times what? A. This is raised power of 2. This is raised power of minus what? 3. What am I going to do? The bases are what? The same. I will take one of the bases and do what? Add the powers. Simply by doing what? By saying that this is A. This is what? 2 minus what? 3. Of which is going to give me A power what? Minus 1. Do you understand? So the same method is applied here. Now this is meter power. Now by the time you multiply this, because the bases are the same, right? You have meter power 1 and meter power minus 2. So let's work it out, okay? By simply saying that this is This one is just kilogram on its own. We say kilogram m 1 minus 2. Hope you understand now. Okay, now per second square. Okay, now let's work it out. So what do we have? We have kilogram 1 minus 2 is equals to minus 1, right? So this is minus 1 per second square. This is just the unit of pressure. I had to go this far to explain in case you're asked to state the unit of pressure. Do you understand? Now, what is the dimension? So let's go to dimension. When to get the dimension using these three units, we have the length, the mass, and the time. They are very, very important. They are the three main fundamental units. Okay, now anywhere you see kilogram, kilogram is a measurement for what? Mass. You're just going to write capital M instead of writing the mass in full. That becomes the dimension of kilogram. Do you get it? Okay, so you're going to write what? M. Now when you see meter, meter is unit for length. You're just going to write capital what? L. Okay, now retain the power, which is minus 1, right? Okay, for the seconds, we're just going to write capital what? T and minus 2. Is that clear? Now, this is the dimension of pressure, which is what they asked us to find. So, in case you see something similar to this, you can use the way I explained to be able to get your correct answer. From what we've done so far, the correct option to this question is option A. If a car starts from rest and moves with a uniform acceleration of 10 meters per second square for 10 seconds, the distance it covers in the last 1 second of its motion is what? Option A, 95 meters. Option B, 100 meters. Option C, 500 meters. Option D, 905 meters. In solving this question, you must note that once a body starts from rest, whether a car or anything that starts from rest, that means it was resting before it started making movement. So at that point that it was at rest, we assume that it was not moving. So its initial velocity becomes what? 0. Okay, so let us take the parameters we have. We have u is equals what? 0. It moves with a uniform acceleration of 10 meters per second. That is my what? A. Okay, for 10 seconds, that means that time is 10 seconds. The question says, calculate the distance covered in the last 1 second. In the last 1 second, note that. So we're looking for x. Now, before we can talk about what to do, you must remember that we have the equations of motion. So I'm going to state it here so you can know the particular equation that will fit into what you are looking for. So let's go. I have equation 1. V is equals u plus at. V square equals u square plus 2as. X equals ut plus half at square. X is equals u plus v over 2 bracket what? T. Now look at it. This equation will help you to solve some other problems on motion. So let me explain. So which equation is going to go into what we have? So we're going to look at the parameters given, including the one we are looking for, before we can even analyze the question. So let's go. Now look at this. This equation cannot go v equals u plus 80 because we have distance x, but there is no distance in this particular equation. So this will not work. Do you understand? Okay. Coming to the second one. From the question or from the parameters given, we do not have final velocity. So for this particular one, it will not go because it has final velocity. So this is gone. I hope that is clear. Now looking at the third one, We have x, which is the distance. We have u, we have t, we have a. It seems like it has everything that we need, but let's just mark it what? Good. And go to the next one. Look at the final one. It has final velocity, which is v. Because of this particular v, it will not work. So just cancel it. So the equation we are going to use for this question is equation 3, which is s equals to ut plus half at squared. I hope that is clear now. Now using this equation, x equals ut plus half at squared. You must look at the question closely. You understand that it says the distance covered in the last 1 second. That means last 1 second. You're not going to calculate the time entirely. If you calculate the distance when the time is 10, then the last 1 second means when you subtract 1 from 10, it's going to give us what? 9. So you're going to calculate the distance when the time is 10 seconds, and I'm also going to calculate the distance when the time is 9 seconds, which is the last 1 second. Then you find the difference between them. That is what we're actually looking for. So let's work it out. So I'm going to solve with the first time, okay, which is maybe say the last 1 second when the time is what? 10. And I'm going to also solve for when the time is what? 9. That is the last 1 second. But there is a short method to do that by working on the time straight at the same time. Now what you are going to do is to find our distance when t is what? 10 seconds, okay? But the question says in the last 1 second. That means after solving the distance when time is 10 seconds, the last 1 second means you're going to still solve for distance when time is what? 9 seconds. Anything we have, we'll find the difference between them. That becomes our answer. Is that okay? So let's solve by saying for this one, this is x is equals to u is 0, 0 times 10 plus 1 over 2 times 10 times 10 square. Okay, now because this is 0, everything changed to 0. So x is equals to 1 over 2 times 10 times 100. Okay, now this can cancel this to give us 1, can cancel this to give us what? 50. So by the time you multiply, we're going to have 500 meters. This is when the time is what? 10. So let's get the distance when the time is what? 9. So using the same method, we say 0 times 9, then plus 1 over 2 times a is 10, then times 9 square. Okay, now this changed to 0. This is 0 is equals to, this is 0 plus 1 over 2 times 10 times 81, right? Now this can cancel this to give us what? 5. 81 multiplied by 5 is going to give us 405. Sorry, 405 meters. That is my what? My S9. So the distance I'm looking for is what? X10 minus what? X9. That is 500 minus 405, okay, which will give rise to what? 95 meters. Is that clear? So this is how to solve this type of problem. Hope that is clearer now. So if you see this type of question or something similar to it, but if they say the last 10 seconds or in the last 4th second or in the last 5th second, okay, you're going to look for the distance when time is at 5 seconds, and also going to look for the distance when time is at 4 seconds. Then you find the difference between them. I hope that is clear. Now from what we've got so far, the correct option to this question is option A. A car of mass 1,500 kilograms goes round a circular curve of radius 15 meters at a speed of 40 meters per second. The magnitude of the centripetal force on the car is what? Option A, 1.2 times 10 to the power of minus 2 Newton. Option B, 1.2 times 10 to the power of 3 Newton. Option C, 4.8 times 10 to the power of 3 Newton. Option D, 4.8 times 10 to the power of 4 Newton. So you must remember that in every physics question, they have the formulas attached to it. So but first thing first is to state the parameters, which will help you to know the formula. They say centripetal force and not normal force and not gravitational force. So they are being specific, centripetal force. So let us state the parameters that we have. We are given a mass of 1,500. So my mass is equals to 1,500 kilograms, right? And the radius is given as 50 meters. So my radius r is given as 50 meters. Now we have the speed, which is the velocity. V is given as 40 meters per what? Second. So what are we looking for? The acceleration in a circular path is called centripetal acceleration. Okay. The force generated by an object that moves around the circle is called centripetal force. It is different from gravitational force or electric force. So they are specific. So the formula to this question is F is equals to mv square over r. Okay. So this is centripetal what? Force. So where m is my mass, v is the velocity or the speed, and r is the what? Radius. So let's just put it into what we have. That's all. So we have this is 1,500 multiplied by my v is what? 40. And remember, this is 40 square. We can just say 40 multiplied by what? 40. We are still correct. So divided by what? 50, which is happens to be my what? Radius, right? So let's work it out and see what we have. This will give us 2400000, right? We are going to divide it by what? 50. This cancels this, okay? So we go. So by the time we divide, it's going to give us 48000 Newton, okay? Of course, the answer is kept in standard form. So let's work it out by going this way. This is 1, 2, 3, 4, right? So that is 4.8 times 10 to the power of what? 4 Newton, right? So this is how to solve this problem on centripetal force. But you must not forget that centripetal acceleration, in case you are asked, is equals to AT is equals to V square over what? R. This is centripetal acceleration. Why this formula is what? Centripetal force. And from what we've got so far, the correct option to this question is option D. Find the frequencies of the first 3 harmonics of a piano string of length 1.5 meters if the velocity of the waves on the string is 120 meters per second. We have the following options. Option A, 40 Hz, 80 Hz and 120 Hz. Option B, 80 Hz, 160 Hz and 240 Hz. Option C, 180 Hz, 360 Hz and 540 Hz. Option D, 360 Hz, 180 Hz and 90 Hz. The question says, find the frequency of the first 3 harmonics of a piano string. Now, what is the first thing that will come to your mind? What is a piano string? Is it an example of closed pipe or what? An open pipe. So a piano string is an example of what? An open pipe. So how does it flow? What are the harmonics of this open pipe? So let me shock you. The harmonics of this open pipe is what? We have harmonics. It ranges in this form. Fundamental frequency, we have what? 2F0, 3F0, 4F0, 5F0. Is that clear now? So this is the first harmonics, this is the second harmonics, and this is the third harmonic. So what you're looking for is the first, the second, and what? And the third. Remember, if you are dealing with overtones, in case you see overtones, this is what? First harmonics but 0 overtones. Why is it 0 overtones? Overtones are the whole number multiples of the fundamental frequency. So any whole number that is higher than this fundamental frequency becomes the first overtone. So this is what? The second harmonics but the first overtone. This is what? The third harmonics but the second overtone. I hope that is clear. This is what? The fourth harmonics but what? The third overtones. Now you're getting it. Okay, so let's go. By stating the parameters given, so let's just find the fundamental frequency first before you can get the first 3 harmonics. So what are the parameters given? We're given the length to be 1.5 meters. So my L is equal to 1.5 meters. The velocity of the string is given by 120 meters per second. So we have the velocity is given by 120 meters per second. Okay, so remember that the distance between node and antinode is lambda over what? 4. Now we have this is node and we have antinode. Distance is what? Lambda over 4, which is what? L. Okay, but in open pipe we are dealing with what? Node and another node. Then we have two adjacent nodes. So this is what? Distance between node and another node is equals to lambda over what? 2, right? Now this is equals to what? The L. So if you want to make lambda the subject, we're going to say this is over 1, right? Cross multiply. So lambda is equals to what? 2L. I hope that is clear. Alright, so coming to the velocity of sound wave, we have what? We have that what? V is equals to F lambda. But because you're looking for the fundamental frequency, this becomes the least frequency at which sound is heard, that is F naught. Now making it the subject simply by dividing both sides by what? Lambda. So we have divided by what? Lambda. This cancels this, right? So my F naught is equals to what? V over what? Lambda. But what is my lambda here? My lambda is what? 2L, because we are dealing with an open pipe. I hope that is clear. So this is what? V over what? 2L. So this is my fundamental frequency. So I can now solve for the first harmonics, second harmonics, and what? The third harmonics. So let's go. My F naught is equals to V over what? 2L, which is 120 all over 2 times 1.5, right? Which will give me 120 all over what? 3. Of which when we divide is going to give us what? That is going to give us 40 Hz. So my F naught is equals to what? 40 Hz. I hope that is clear. Now for me to get the second one, I'm just going to say 2F naught, right? Which is 2 times 40 is going to give me 80 Hz. Okay, then 3F naught is equals to 3 times 40 is going to give me 120 Hz. So the first harmonics, second harmonics, and third harmonics, they are what? I have 40 Hz, 80 Hz, and 120 Hz. Hope that is clear. So this is how to solve this type of problem. And from what we've got so far, the correct option to this question is option A. A sonometer's fundamental mode is 50 Hz. What is the new frequency when the tension is 4 times the original? We have the following options. Option A is 25 Hz. Option B is 100 Hz. Option C is 200 Hz. Option D is 250 Hz. Now for us to solve this question, we have to relate that a sonometer, the frequency of a string, which is a sonometer, is relates with the tension in the following formula. So let's go. F is proportional to the root of what? The tension. Is that clear? Now, because we are equating them, it varies. We are going to do what? Remove this proportionality sign to introduce a constant. So F is equals to K root of what? T. So what do we do next? We divide both sides by root of what? T. Root of T. This cancel out. So F1, because we are equating, because it varies, F1 over root of T1 is equals what? F2 over root of what? T2. It's as simple as that. So let's look at the parameters given. The first frequency, which is the frequency 1, is given as 50 Hz, right? But now the tension, now they said the tension, which is the second tension, if you see this type of question, it means that the second tension was 4 times the original tension. That means the T1 becomes T, while T2 becomes 4T. That is just it. So let's go. We have that T1 is equals to T, right? Then T2 is equals to 4T. I hope that is clear. So we are looking for the second what? Frequency. Now we can work it out by saying this is F1 over root of T1 is equals to F2 over root of T2, right? By saying cross multiply, F1 over F2 is equals what? Root of T1 over root of T2. Now we can still interchange it by saying or F2 over F1 is equals to root of T2 over root of T1. They are still correct. Now what is my F2? That is what I'm looking for. Over my F1 is what? 50. Then is equals to what is my T2? I have root of 40, right? Then my T1 is root of what? T. Of which is the same thing as saying this is root of 40 over what? T, right? Now this can cancel what? This, and we are left with what? Root of what? 4. So F2 over 50 is equals to root of what? 4. But this is a perfect square, so root of 4 is equals to what? 2. That is F2 over 50 is equals to what? 2. This becomes over what? 1. So if you say cross multiply, therefore my F2 is equals to 50 multiplied by 2 and is equals to 100 Hz. I hope that is clear. So this is how we can solve this type of what? Problem. From what we've got so far, the correct option to this question is option B. If this video was able to help someone out there, please don't forget to subscribe to this channel and turn on the notification button to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this same forthcoming exam can see it and learn from there. I will see you next time in the next episode. Bye for now.